Okay, we're going to look at the second video in this short series devoted to this very interesting routine entitled Proof That Opposites Attract. We're going to ratchet up the sophistication a little bit to the intermediate level. Okay, now it is true for this one, you actually do need 6 red and 6 black. For the basic one, you could have any number of red and black as long as you have equal numbers of each, okay? But here it's actually important that we have a total of 12 cards, and we'll explain exactly why that is the case, okay? So what we do here is we, as before, have the spectator randomly stack these together. Maybe they'll put the red on the black. That's just fine, okay? And then we're going to Klondike shuffle the cards. Okay, so that's what we did in the basic routine as well. In fact, I'll probably tell you where we deviate. Okay, so that's the same. Now, in this intermediate case, we're going to perform the Charlier shuffle. Okay, now I do have a separate video on the Charlier shuffle. This shuffle is worth mastering if you're at all interested in math card magic. Okay, so this is where you push off any number, and then from the bottom you deposit some on top. Then from the top here you put some on the bottom, and then the rest go on top. Okay, so that's called the Charlier shuffle. Now we're going to ask the spectator to tell us when to stop dealing. Maybe they'll say stop there, and that's just fine. And now what we're going to do is we're going to perform a rosette shuffle. You just spin those, bring those together however they will. Okay, so it's a bit of a mess actually. Okay, and then from there we're going to perform a mange, over, under, or under, over. And the spectator can decide this. So maybe they'll ask for an under, over, under, over, under, over, under, over, under, over, under. Okay, that's a mange. Okay, and now what we're going to do, and that's the same as the basic case, so we haven't, that's not different. And then we deal out into 2 piles, which we've done before with random stacking decided by the spectator. That's really important. Okay, and maybe they'll ask for right on left. Now, you can actually do as many of those as the spectator calls for. You really can. You can do 5 million of them if they have the patience. Okay, but what we're going to do beyond 2 piles, we're actually going to deal into 3 piles with random stacking left to right or right to left. Maybe they'll go left to right. That's just fine. Maybe we'll do one more of those. Okay, 3 piles. Okay. Maybe they want left to right again. That's just fine. They can choose either direction. And then we're going to deal into 4 piles. 1, 2, 3, 4. This is crazy. Think about how these cards are being moved around. Oh, so left to right, right to left, left to right. Okay. So that's just fine. So you can do as many of those as you like, from left to right or right to left. But we can also do something called a leapfrog stacking, which is a really fun one. So this is where you go from left to right or right to left, but the cards jump over their neighbors. So for example, the leapfrog stacking from left to right would look like this. This pile leaps over its neighbor, lands there. This one leaps over its neighbor, lands there. And then we randomly stack these, however the spectator calls for. Okay, so you can do that from either direction, and you can do as many of these as you like. Maybe they'll do a leapfrog from right to left. That's fine. You leap over the neighbor, leap over its neighbor, random stacking here. Maybe they'll go like that. Okay, and we can even deal into 6 piles. 6 piles. Okay. And you can stack from left to right, just normally, right to left, normally, or leapfrog stacking from left to right or right to left. And you can do as many of all of those shuffles as you like, or the spectator asks for. Okay, so maybe we'll do a left to right leapfrog, kind of a fun one to do. Okay, with random stacking here, of course. Maybe they'll go like that. Okay, so that's all new. Dealing out into 3 piles, 4 piles, 6 piles, and then with this leapfrog stacking, that is brand new. We did not do that in the basic routine. Okay, and then at this point, we're finally going to confirm that indeed opposites attract. Oop, seems to be the case so far. Yep. Yes, indeed. We have just confirmed the truth of this aphorism. Opposites do, in fact, attract. Okay, so let's look at some of the mathematics for this one.